So yung next topic natin is the design of compression members. So we have here an example. So last week, yung example doon sa ating video, doon sa ating compression member is just the analysis ng ating compression member. So ngayon, magdi-design tayo. So we need to select trial section and check if that trial section is conformable with our compression stresses provision ng ating NSCP. So we have here an example. A column effective length is equal to 7 meters. So effective length na yung 7 meter. Using both, so pag sinabi nating effective length pala, ito, pag sinabi nating effective length, yung K natin, na-multiply na dun sa ating length, di ba? Kasi effective length na yan. May nag-i-in. Okay. Okay. Is 7 meter. So using both yung LRFD and ASD natin, we need to design an A36 wide flange steel column. So pag sinabi nating A36, yung FY and FU natin is 248 and 400 megapascal. Okay. With the nominal depth of 410. So meron na tayo actually depth dito. Sinabi na sa problem natin na meron yung depth natin, which is 410. Specified na ang depth ng section natin is 410 dapat. So pag wala kasing specified dito, marami tayong trial na gagawin. Diba? Pag walang specified na depth, marami tayong trial na gagawin kasi within doon sa ating initial na gross area, maraming section ang pasok doon sa area na yon. Pag tinignan ninyo doon sa ating steel members, yung section natin that is given by the AISC, ang dami nating steel section. So, initially, dapat may idea ka kung ano yung preferred or ano ba yung gusto mong depth nung cross-section mo or yung member mo. So, pag nasa field ka, architect, ano ba yung plano natin for the depth? So, dapat meron kang initial na depth mo sa iyong cross-section. This is to limit yung trial mo when you design a particular section ng member. Kasi pag wala kang initial na depth, lahat ng pasok sa AG, yung ating gross section, kailangan mo silang itry. And that will be very difficult and time-consuming. Kasi ang daming section doon sa ating AISC. Paano kung pasok silang lahat? O, di ba? So initially, dapat may tawag nito, meron ka ng specified na depth para sa iyong design sa member. Okay, so we have 410 mm. So pag specified na yung depth natin, mag-aano na lang tayo doon sa ating weight, yung weight. Kasi di ba ang section is depth by weight. That is our service loads. Yung service loads daw natin, we have the dead load of 400 kilonewton and we have the live load of 900 kilonewton. So also we have to check our section against the local stability. Ito yung ating slenderness ratio that should not exceed doon sa 200. Itong local stability natin. So, i-check din natin siya. Okay? So, we will design a section with a depth of 410 mm using both LRFD and ASD. So we have the solution. So let's try first our ASD. And according to our code provision, our factor for ASD, o hanggang ngayon may nag-a-admit pa, nagpapa-admit. Yung factor natin for ASD is 1.67. So we have given dead load and live load. So yung load combination natin, if we use ASD, is yung dead load plus live load. Ito siya. Yung load combination natin sa ASD is dead load plus live load. That is equal to 1,300 kilonewton. So that is 400 plus 900. Di ba? And since wala pa tayong cross-section, kasi yun nga yung hinahanap natin, wala pa tayong properties ng section, such as yung radius of gyration na gagamitin natin in determining yung our slenderness ratio, we try this value, that our FCR is equal to 0.5 of Fy. That is the arbitrary choice based on the experience. So 0.5. So that will be our baseline or benchmark in determining our gross section area. So yan yung magiging arbitrary benchmark natin, baseline natin. That is the arbitrary choice based on the past experience. So we need to try our FCR is equal to 0.5 of Fy. Okay? So yung ating FCR, which is our flexural buckling stress, is equal to 124. That is 0.5 times yung Fy natin na 248. So that is 124 MPa. So meron ka ng FCR. So ang sabi sa code, our allowable strength should be greater than our PA, yung ating service load. Ito yung PA natin dito, that is 1,300 kilonewton. And our nominal, this is our nominal strength is equal to FCR-AG. That is in our code pa rin. That is FCR-AG. So if we substitute yung formula or yung equation ng PN dito, ang lalabas na equation natin is this. We have FCR times AG over our factor. This should be greater than our service load. Okay? So ito yung arbitrary natin. So anong gagawin na natin? We need to find the required area para makakuha tayo ng section. So ito, meron na tayong FCR. We also have this factor and we also have our load combination. Yung required area gross natin should be greater than or equal to this equation. So minanipulate ko lang itong equation, ito yung kalalabasan niya. And if we substitute yung value ng ating PA, yung ating factor over FCR, ang value na makukuha natin is equal to 17,508.06 mm squared. So ito yung required area nung ating section, that is 17,508.06. Okay, now, ang susunod na gagawin ninyo, if tapos nyo nang ma-determine yung required gross area natin, is i-check na ninyo doon sa steel table natin. Mag-check na kayo ng section na 410 kasi nga sabi natin specified na yung depth, that is 410 based on this computed gross area. Okay. So yung kinuha ko, nag-base ako doon sa book of yung strength of materials kasi yung sa last page meron tayong steel properties doon. Okay? Nag-base ako doon. However, later on, magbibigay ako ng Excel nung steel properties at doon kayo magtingin ng section para pare-parehas yung values natin. Kasi in other books, hindi naman masyadong kalakihan yung tawag nito, yung difference, yung 0.01 mm, mga ganon. Pero later on, magbibigay ako ng AISC table para pare-parehas. Doon tayo titingin ng section. So from steel table, we need to find section that is 410 mm in depth based on our gross section. So ito yung tawag nito. Ito yung nakuha ko doon sa book nung strength, the steel properties. So 410, magtingin lang tayo sa 410 kasi naka-specify na yung 410. Pero pag hindi naka-specify yung depth, you need to try all possible sections. Okay? So yung 410, ito yung depth natin, ito yung area, ito yung section modulus natin, ito yung RY natin. So ito yung section natin. So titingin daw tayo dito sa ating steel table na yung area natin should exceed this value. So yung required area natin should exceed this value, that is 17,508,000. So pag tinitignan natin ito, if we check our table, so anong section yung mas mataas doon sa ating 17,508 na area? Itong section. So itong section. Kasi pag tinitignan natin yung area natin, that is 19,000. This is greater than ours computed dito na 17. Kasi dapat daw yung required area natin should be greater than 17,508. So ito, itry natin itong section which is 410 by 149. So kukunin natin yung section, kukunin din natin yung properties. So we need to try So we need to try 410 by 149. Okay? So yung area natin dyan is 19. Yung Rx natin is 180 and yung R natin is 63.9. That is all the properties of that section. Okay. Meron na tayong radius of gyration, meron na tayong area gross. We can now check the adequacy ng ating section. Diba? We can now check yung ating allowable design strength is greater than or equal to our service loads. Diba? Okay, meron na tayong properties. Okay? So checking for our adequacy, kukunin natin yung balik na tayo doon sa analysis ng ating compression members. Diba yung first step natin is we need to identify what type of column, intermediate ba or long column. And to identify the type of column, we need to solve our effective slenderness ratio and compare it with our critical slenderness ratio. So our effective slenderness ratio maximum, ito, yan yung value natin. So that is 109.55. And if we compare this with our limit, which is 200, okay siya. So stable pa naman siya, yung local stability natin. So okay siya. And then we need also to solve yung CC natin. This is equal to this value. Okay? So yung value yan, given naman. So you just have to substitute in our equation. Masosolve ninyo yung value natin. So comparing our SR max and yung CC natin, what is the type of our column? That is an intermediate column. Diba? So far, may question ba? So far. May question ba? Wala pa. Wala pa naman. Okay. So pag na-determine na natin yung type of column natin, alam na natin kung anong flexural buckling stress ang gagamitin nating equation. That is an intermediate column. Since our column is an intermediate column, we will use this equation. That is the FCR is equal to this values and equation. Yan. Kasi nga intermediate, ito yung gagamitin nating equation. Okay? So we need to first solve yung FE natin before solving our FCR. Solving our FE, our value now is equal to 164.48. Yan yung FE natin. So, etong susunod na actually na solution natin is actually analysis na ito that is given to you last week. So, yung FE natin is equal to 164.48. So, masosolve na natin yung FCR natin. You just have to substitute yung values na na-compute natin. That is equal to 131.94. Okay? So, meron na tayong FCR. Meron, given na din yung factor natin because we are solving ASD method. Mache-check na natin if our allowable strength is greater or equal to our service loads. Okay? So, substituting yung values na na-solve natin, yung FCR, meron na din tayong AG, meron na din tayong tawag nito, factor, yung omega natin, masosolve natin yung ating allowable strength, which is Pn over yung factor. That is equal to this value in Newton. So we have 131.94, ito yan, yung na-solve natin dito. We have 19,000, that is the gross area of our trial section, that is 19,000. And yung 1.67, that is the factor using ASD. So yung value natin is this value in Newton. Kasi this is in MPa, this is in mm squared. So ang lalabas dito is in Newton. Okay. So that is equal to 1,501.11 kilonewton. Okay. So our allowable strength now is this value. We need to compare it with our service loads. So if we compare the two, these two, is our trial section safe or it fails? Any one of you? Anyone from the group? So comparing these two, ano na yung magiging yung trial section natin? Mag-fail ba siya or hindi? Miss Del Rosario. Miss Del Rosario.
Ma'am?
So meron na tayong values on both. Yung ating allowable strength and yung ating service load. So ano yung masasabi mo dito sa ating trial section? This is 410 by 149. Pag kinumpare mo itong dalawa, mag-fail ba siya or hindi? O anyone? Oh. So if you know the answer, you just have to open your mic and give me the answer. This is a graded recitation, actually. And graded recitation is, tawag nito, kasali siya sa quiz. Ang gagawin ko, kasali siya sa quiz. Hindi sa seat work, hindi sa activities. And you know that quiz is around 40% of your grades. So pag alam niyo yung sagot, o anyone from the group, so mag-fail ba siya or hindi?
Ma'am.
So, hindi. Sino yung nagsalita? Si Mr. Sakyab. So, hindi siya mag-fail. Kasi nga, yung ating allowable strength is greater doon sa ating service load. So, our section is safe. Yung ating trial section na 410 by 149. So, safe yung trial section. Ang tanong, it is safe, but the question is it economical? So we don't know if it is economical. Diba? So we need to check another trial section. Safe yung ating 410 by 149, diba? Pero ang tanong, is it economical? Diba? Kasi yun din yung isang factor in designing structural members. Diba? Yun yung tanong, is it economical? So we need to check or we need to try another section. 410 pa rin tayo kasi naka-specify na sa problem natin that our depth is 410. Okay? So we need to try another section. Okay, eto. Parehas pa rin actually yung process. Dito, balik tayo dito sa steel table. We need to check another section. Okay. Dito sa ating steel table, pag mas may mataas pa dito, kunwari, mas may mataas pa dito sa 410 by 149 na mas mataas pa yung area. And then, etong 132 na mas mababa pa yung area. Ano yung kukunin natin? Yung susunod dito na 149 yung yung sinusundan ng 149. Kung meron, for example, meron tayong 410 by 200 siguro. Let's say we have 410 by 200. Ano yung kukunin natin? Yung 410 by 200 or yung 410 by 132? So ano yung i-check natin na next trial section?
$410 by 200, ma'am.
By 132, ma'am, at
Okay, ituloy mo nga yung. Okay, 132 because
Ma'am, yung
Ay,
149 kat po masasunan tapos may 200 kat mas nangat nga tutumaran sunan hanga mas economical.
okay, correct si Mr. Guzman. We need to check yung next na mas bababa doon sa 149. Kasi nga, 149 pa lang, pumasa na siya. How much more kung mas malaki yung gross area ng ating section. Diba? So yung next na i-check ninyo is yung mas mababa doon sa 149. Yung 410 by 132. So you might be asking, why are we trying to check this section? Gayong yung AG natin dito, ito, is 17. Tapos yung AG natin dito is 16,800 lang. Di ba? You might be asking that question. Kasi itong benchmark natin dito is 17,500 and yung required area natin is should be greater than this value. And yung area natin sa 132 is 16,800. So you might be asking that question. You might be correct. However, that will be or that will not be a concrete basis in determination of the most economical section. Kasi you have to remember that yung AG natin here is just the benchmark based on our assumption dito na yung FCR natin is 0.5 of FY. So, we need to check yung next na section. So, kasi pwedeng yung susunod na section is pumasa doon sa ating load. Diba? Kasi yung ating basis lang dito sa area, sabi ko nga, yung basis natin is just the assumption that FCR is equal to 0.FY. So this will not be a concrete basis to say that our section is the economical one. So we need to check yung mas mababa. Yung mas mababa ang area. Kasi nga, sabi ni Mr. Guzman, and I will agree with that, yung pag yung mas mataas yung kukunin mo, mas lalo siyang papasa, hindi na siya mas economical. Diba? Mas economical pa yung 149 kaysa doon sa 410 by 200 if mayroon pang 410 by 200. So we need to check the next section which is 400 by 132. So the same process, kinuha natin, the same process nung sa last slide natin. Meron tayong area gross, Rx, and Ry. This is Ry. So we need to check the adequacy, yung SR max, umasa siya sa ating 200, yung limit ng slenderness ratio natin. Yung CC natin, we need to compare these two to know what type of column. So, yung CC natin is mas malaki pa rin siya sa KL over R. So, yung column natin is an intermediate column. So, since intermediate column, we will use this equation. Yan. Uulitin lang natin actually yung ginawa natin kanina. And then yung value ng FCR natin. That is 130.38. And we need to check again if our allowable strength is greater than or equal to our service load. Diba? So yung PN natin is equal to this value, 1311566.9. Okay? So if we try to compare our allowable strength and our service load, mas mataas pa rin yung ating allowable strength kaysa doon sa ating service load na 1,300. So, ang ating 410 by 132 na section is still safe. Diba? Safe pa rin siya. So, ito, mas economical siya kaysa doon sa ating previous trial. So, if you're a designer, di ba, kailangan natin safe. Kailangan din nating most economical. Kasi kasali yan sa inaano natin, yung cost ng ating design, di ba? So pipili kayo doon sa dalawa, safe silang parehas. Okay, that's given. Safe silang parehas. Yung mas economical, pero yung mas economical, itong 410 by 132. Okay? So far, do you have any question? So far in our problem? Wala pa naman. Okay. So yung answer natin dito is 410 by 132. So the same problem, this time we will be using yung LRFD method. So we have here, okay, that is our factor for the LRFD. And for the load combination of LRFD, yung ultimate load natin, that is the factored load, yung 1.2 dead load plus 1.6 live load. Yun yung gagamitin natin for LRFD. Factored load yung gagamitin natin. That is equal to 1,920. Okay. So the same process pa rin siya. Ulit-ulitin nyo lang siya. So we need to try our arbitrary baseline, yung choice based on our experience to have our value for FCR. That is this value. So yung FCR natin is equal to 124 pa rin siya. Okay, the same. Yung ating design strength is equal to our factored times yung nominal strength natin. This should be greater than or equal to our ultimate load, yung PU natin. Okay, so we need to solve our required AG that is equal to this value. So, pag meron na kayong required AG based on the arbitrary choice, makakakuha na tayo kung anong section yung itatry natin. Okay? So, based on this required AG, pag tinitignan natin, anong itatry natin? Diba? So, itatry natin ulit yung 149 kasi siya yung pumasok doon sa ating AG, di ba? Yung 149. So, i-check pa rin natin siya to just show yung sa ating example. So we have to try this again. Ayan. So, hindi ko na i-discuss ito since parehas lang doon sa dalawang past slide natin. So, yung una, you have to check yung what type of column, yung type of column natin by comparing yung SR max and CC natin. So, yung column natin is an intermediate. Ito pa rin yung gagamitin nating equation. And we need to solve FE before we need to solve FCR. And then, we need to compare yung ating design strength doon sa ating ultimate load. Our design strength should be greater than or equal to our ultimate load. So our design strength is equal to this value. Diba? Yung nominal strength natin is FCR over AG. I-multiply natin siya sa phi. Yan yung ating design strength. This is equal to this value. Okay? In Newton pa rin siya. So if we compare this design strength doon sa ating ultimate load, mas malaki siya. So, safe yung ating trial section natin. Okay? So, i-check pa rin natin ulit doon yung susunod na section natin which is the 410 by 132. I-check lang natin kung papasa pa rin siya. Kasi minsan, yung value natin na susunod, papasa. Minsan, hindi naman. Diba? So we need to check. So we need to try 410 by 132. So checking yung adequacy natin. Yan yung type of column natin. So ulitin nyo lang din yung gagawin ninyo. So we need to use this equation, solve for FE, and solve for the value of FCR. And then you need to compare yung design strength doon sa ating ultimate load. So our design strength is equal to this value. So yung mga value na ito, given naman na siya, isubstitute nyo lang dito sa equation. So our design strength is equal to this value, which is actually greater than our ultimate load. So safe pa rin yung ating trial section. So yung trial section natin using LRFD is 410 by 132.